Senses is the last session, and we're going to look at them in a series of clips. So let's begin with looking at the function of receptors. Now, up until now, we've talked about receptors in terms of the nervous system, and we said that a receptor picks up some change in its environment. That change can be things like light, temperature, sound, oxygen, concentration. So the stimulation is enough that it'll trigger or cause an action potential along the neuron. Okay. From there, the information travels to the CNS. If you recall, it's going to be processed. We're going to interpret it, and we're going to remember it, a sensation. Okay. So the first time you taste an avocado, you're tasting what it tastes like to you. You're remembering what it feels like. You're remembering the room that you're in, and if you know you're in a new restaurant or something. Those are all examples of how we record information. So there are 5 major types of receptors: mechanoreceptors, chemoreceptors, thermo, nociceptors, pain, and photoreceptors. All of those are examples. So mechanical receptors just do that. They sense change in pressure, fluids particularly. So, for example, in your vessels, in your body, there are pressure points which are just like the motion sensor outside your house to turn on the light when you come in with an armful of groceries. So these mechanoreceptors are sensing the fluids that are going by. Is there enough of it? Is there too much? Is the pressure too high? What's the concentration of particular ingredients like oxygen? Chemo is stimulated by changes in chemicals. So this is highly associated, of course, with taste and smell, and senses various chemical changes. Thermoreceptors sense temperature, hot and cold, obviously, and nociceptors, pain, tissue damage. Remember when we talked about the skin, I said, you know, when you push lightly on the skin, it feels pressure, but nice pressure. But if you grab someone's arm quite hard and started to push down on it, that would sense that this pressure you're putting on my arm might hurt me, or tissue damage. And of course, photoreceptors are in the eye. So this is a picture we've looked at before, and I'm just again bringing it forward because of the various receptors that you see. Okay, just again sensing pressure, touch, pain. What is the definition of sensation? So this is the interpretation of sensory nerve impulses by the brain and makes us aware of some kind of event, whether it be internal or external. It's a perception. Everybody's perception is different. It's just like they say pain is whatever the person says it is. Sensory information is carried to the brain. The brain takes it and figures out what it is. It goes to the part of the cortex. Remember, that's the covering over the top of our brain where all the cell bodies are, and it decides what it is. That feeling, however, may come from the receptors, like your photoreceptors in your eyes, but in actual fact, we're interpreting it in our brain, but we project it back to our eyes so that it seems like your eyes are seeing that. Now, we talked about the thalamus earlier that says chapter 9, but it might be session 9 probably, related to the thalamus. And we have ascending axons coming up. So let's look at that. So here's our brain. Okay, information is coming up. Your thalamus is somewhere around here. And when it gets to the thalamus, it's on its way to the cortex, but when it gets to the thalamus, what's happening is it stops there. And in the thalamus, what happens is it tends to figure out what it's going to do. Okay, and that figuring out of what it's going to do is like a little relay station. And recall we said that the thalamus senses things, crude information. They can't totally interpret it, but it's They sense there's pain. They sense there's temperature, touch, and proprioception. And proprioception is, do we know that the position of our limbs? Visceral sensory neurons, so those are those that are going to I'm going to go to a picture here. Okay, so we have sensory neurons that share visceral, so visceral meaning an organ here, versus our sensory or somatic pathways. And you can see they're coming in and they start to share a pathway here. When that gets into our brain, sometimes our brain confuses which one's bringing what, and it projects it backwards. So by projecting it backwards, it says, okay, you've got arm pain, but in actual fact, the problem is in your heart, and that's what we call referred pain. So you notice then, if someone's heart is right here and the pain is trying to get up to your brain, it might come back and say, oh, you've got arm pain, which is why, of course, whenever someone has pain in their neck, jaw, or arm on that side, if they came into the emergency room, we do a cardiogram right off the bat, just to be sure. And what's happened is the pathways are being confused, and we get the phenomena of referred pain.